Welcome to This Explainer, where we take the frankly overwhelming world of Python and, well, chop it down into simple, digestible building blocks. Look, if you've ever stared at a screen full of code and felt completely lost, you are absolutely in the right place. Today, we're going to break down Python from complete first principles.
So we got to address that anxiety right out of the gate. Is programming really that scary? Honestly, no way. We're going to prove to you that programming is literally just giving step-by-step instructions to a really, really fast, highly reliable computer. It's exactly like handing a friend a super specific recipe for making your breakfast. The computer is just like that friend, except, it processes those steps at lightning speed, and unlike your friend, it doesn't ever complain about doing the dishes. We just need to learn how to speak its language. All right, so here's our roadmap to getting you to your first real application. We'll be covering 1. Speaking the computer's language, 2. Storing data in boxes, 3. Making logical decisions, 4. The power of loops, 5. Reusable code with functions, and finally, number 6, bringing it all together. Let's just dive right in. Section 1. Speaking the computer's language. Okay, we're starting with the absolute basics of communicating with the machine, using the universally recognized programmer's icebreaker, the built-in print function. By simply typing the word print, followed by a set of parentheses, we're telling the computer to spit text out directly onto the screen. Whatever you place inside those quotation marks, like in this case, hello world, is exactly what the computer is going to repeat right back to you. Boom. That's your very first successful instruction. Section 2. Storing data in boxes.
Now, to do anything actually useful, a computer needs to remember information as it works, right? So think of variables as basically labeled memory boxes where you can stash away your data. When you tell Python that name equals Alice, what you're doing is grabbing a box, slapping a label on it that says name, and tossing the word Alice inside. Later on in your code, instead of typing Alice a million times, you just call for the name box, and the computer instantly knows exactly what you're talking about.
Now, Python is pretty smart, so it categorizes this data into different types so it knows exactly what operations are allowed. First up, we have strings, which are just text characters wrapped up in quotes like Alice. Then we've got integers. Those are your whole numbers, like 25. If you need a bit more decimal accuracy, you'd use a float, something like 5.6. And finally, we have booleans. These are incredibly simple but super powerful logic switches that can literally only ever be true or false. That's the whole shebang.
So the really crucial point here is that context completely matters. Because Python knows the difference between text and numbers, using the exact same plus sign does two totally different things depending on the data type. Adding the strings Mike and Jane together, that just glues the text into one giant word, Mike Chain. But if you drop that same plus sign between the integers 5 and 6, Python does the actual math and gives you 11.
But hey, what if you need to store a bunch of items in a single memory box? Well, Python has these specialized, highly organized collections just for that. Need a shopping list where you can add or remove items? Use a list. Need rigid, totally unchangeable dimensions? Go with a tuple, which is perfect for stuff like screen resolutions, say 1920 by 1080. Sets are clever little collections that automatically strip out any duplicate values. And dictionaries? They store data in key value pairs, meaning you can easily look up the key name and instantly grab the value Alice.
Section 3. Making logical decisions.
All right, up to this point, our code is, well, kind of static. To give our programs actual brain power and make them interactive, we need them to make choices. We do this by using if, else if, which Python actually shortens to elif, and else statements. We pair these up with comparison operators, greater than, less than, or equal to. For instance, if a user types in a number, we can write an if statement to check, hey, is this number greater than 10? If it's true, a specific block of code fires off. If it's false, the program just gracefully skips it and falls back on an else statement, which acts as a default backup plan. This essentially gives the computer a logic tree to follow, depending entirely on what the user does. Section 4. The power of loops. Okay, imagine having to manually type out a greeting or calculate an expense 100 times in a row. Yeah, no thanks. Loops save you from that repetitive nightmare by tirelessly doing the heavy lifting for you. The most common one is a for loop, which lets us easily iterate through a collection automatically. So if we have a list variable called fruits with an apple, banana, and orange inside, we can just write for fruit in fruits, print fruit. The computer automatically dips into the list, grabs the first item, prints it, and then repeats that exact action for every single item one by one until the list is totally empty. Now, while a for loop runs a set number of times based on a list, we also have the while loop. A while loop keeps running continuously as long as a certain condition remains true. So you might tell a while loop to keep counting as long as the count is smaller than 5. But, and this is a big but, you absolutely must make sure to logically break the condition in your code, like adding 1 to the count each time. If you don't, you'll get stuck in an infinite loop that just runs forever and totally crashes your program. Section 5. Reusable code with functions. As our programs start to grow and the code gets longer, we really need a way to organize things without creating a massive, cluttered mess. Look, good programmers are efficiently lazy. We live by this golden rule called the DRY principle. Do not repeat yourself. Instead of copying and pasting the exact same block of code every single time we need to, say, calculate a complex math equation, we write that piece of code once, pack it inside a function, and just reuse it everywhere. Building a function is basically an easy 4-step recipe. First, you define it using the keyword def. Second, give the function a clear name and tell it what input parameters to expect, like a list of expenses. Third, perform your logic and tell it what final result it should return back to you. But here's the kicker. Step 4. A function won't actually do anything on its own. You have to literally call the function by its name in your app whenever you want it to run. Section 6. Bringing it all together. Okay, we've got our 5 core building blocks: basic syntax, variables, conditionals, loops, and functions. Looking at this timeline, you can see how rapidly they snap together to bring a real application to life. By minute 5, you're using variables to store user inputs, like their name. Minute 10, you're setting up if and else conditional logic to read their commands. Minute 15, you're using loops to quickly iterate through a list of all their recent transactions. And by minute 20, you're calling custom functions you wrote to cleanly calculate the final totals. Just like that, by snapping these foundational blocks together, you can easily build a fully interactive personal finance chatbot in under half an hour. It's that fast. And this highlights a genuinely vital reality of programming. You absolutely do not have to memorize everything. Fantastic resources, pocket references, and cheat sheets exist all over the internet to help you out constantly on your coding journey. Honestly, professional developers rely on them every single day. Programming is all about understanding the logic of these building blocks, not just memorizing a dictionary. Now that the intimidation factor is completely gone and you understand the 5 foundational blocks that power Python, you hold the keys to creating essentially anything you can imagine. The logic is simple, the syntax is clear, and the possibilities are literally endless. So the only real question left to answer is, what amazing application are you going to build first?